Hi, in this video we're going to learn how to solve equations using log. We skipped one section, which is some of the log rules, expanding rules, combining rules, but we are going to try to embed it in this section. So I'm going to start with a quick review, which will be answer to the Bellware question. First of all, the ln, as a reminder, refers to natural log. Ln of e equals 1 because we said whenever we see the word or the abbreviation ln, it means it has a base of e. And this will equal to 1 because e to the power of 1 equals e. Ln of 1, regardless of the base, is 0. And this is the explanation. We can put the base right here. And if I do the loop, e to the power of 0 equals 1, which is true. Any number to the power of 0 equals 1. Ln of 0, this is going to be undefined. And the reason why, let's try to remember together the domain. So the domain of the log is 0, comma, infinity, and it's open on 0, which means not included. So it's not an allowed input. So this, if I put it on the calculator, it's going to give me undefined. Ln of -7, also undefined. Negative input is not allowed because 0 to infinity means all the positive numbers, positive real numbers. Now this might be a little bit new. Expand Ln of 1 over x. And this is one of the rules that we want to embed. So Ln of a over b equals Ln of a minus Ln of b. And a quick reminder, when we talked about log, we said the output is an exponent. And now you're going to see that this is so familiar. When we divide, what do we do with exponents? And let's make this a little bit bigger. When we divide, we subtract exponents. So bx to the power of 2. So we are subtracting exponents when we are dividing. This is where that rule comes from. So Ln of 1 over x equals Ln of 1 minus Ln of x. And Ln of 1 is 0, which leaves us with Ln of 1 over x equals negative Ln of x. When we flip, it's a negative exponent rule. So I'm going to start with example 1. And the question is solved, which means we need to find the value of x. When I see log means the base is 10, I will use the loop. And 10 to the power of 2 equals x squared. So x squared equals 100, which means x could equal plus 10 or x could equal negative 10. Now, what did we just say? We can't have a negative input. So we will take the 10 as the only solution. Now we look at example 2 right here. I'm going to go this way. And I see the base, so I'll do the loop. X plus 1 equal, or 2 to the power of 3 equals x plus 1, which makes it 8 equal x plus 1. And x equals 8 minus 1, which is 7. So x equals 7. If I try it in, 7 plus 1 is a positive input, so no problem with this. Now, the next one has a plus, and one of the rules to know is Ln of a plus Ln of b equals Ln of a times b. When we multiply, we add exponents. So we're going to do this equal to Ln of x. Now, one more thing here, a rule that we're going to embed. When we see a number next to the Ln, it's a power. We can raise it to the power. So that could be kicked in as a power. So now what we're going to do, I'm not going to finish it up. We have Ln on both sides, so we can get rid of these. And we're going to distribute And this is gonna combine like terms equal to 0 and solve. It's gonna turn into a quadratic function. Make sure at the very end you go back and check the solution so you don't have a negative input. Similarly, right here, ln plus ln equals ln of the multiplication of these. The number next to it could be kicked in as a power. And so once we get to this step, we can get rid of these, and this turns into a quadratic. Again, this is very similar, this example, except that you see a 0. And we needed ln on all sides to cancel it out. So 0, I can write it as ln of 1. And this is what we saw right here in this rule. So if I get rid of ln, distribute, combine like terms, solve, and I would add check. I want to write one of the rules that we embedded in. A ln of b equals ln of b to the power of a. That's one we kicked in as a power. So I'm going to highlight the rules we used, that we embedded. There's the 3 of them. Now we see e in this next equation. So if I see it on both sides, that means I can easily get rid of it. ln of 2x equals a 3, and the base is e. So 2x equals e to the power of 3, divide by 2, e to the power of 3 over 2. And we can leave it as is because e is a Euler's number. It's a constant. You can get an approximation on the calculator, but you don't need to unless you're asked to do so. And the last one, it's exactly the same thing. It's a duplicate, I think, by accident. Now, one thing is, let's say you have 20 to the power x over 2 equals 5. If we want to solve for x and x is a power, we definitely have this tool of using ln or log on both sides, as long as log of same base. Once we do that, we can kick this out. If it's out, we kick it in. If it's in, we kick it out. So x over 2 times ln of 20 equals ln of 5. And now we can multiply by 2, divide by ln of 20, and we can get the answer. So if we multiply both sides by 2, we will have 2 ln of 5, then divide by ln of 20. So this would be the answer, and we can leave it as is.